So let's continue with using a practical example of the metric system. And I'm going to bring in the thumbs up, thumbs down rule. This is a very common rule that I use throughout science, whether it's biology, chemistry, or physics. Let's say that I have 17 hectoliters. See, there's hecta and liter. And I want to change that to milliliters. So I'm going to work at changing that to milliliters. I need to use my metric progression here. And I can look at it, since I wrote this down, I can see that milli is 1, 2, 3, 4, 5 steps from hectoliter. But I'm going to do it in a way that I feel is even simpler, in a way that will help us in the long run down the road. I always change to my standard. Hecto is greater than liters by 2 steps here, or 10 to the second. Each of these steps is a multiple of 10. So I'm going to actually go from hectoliter down to liter, then from liter down to milliliter. So it's actually a 2-step process. I won't trip on the staircase, if you will. I want to go very simple. I look here, and instead of going directly to milliliter, first I'm going to go to liters. So watch what happens. I have 17 hectoliters, and I want to go to liters. So the first thing I ask is, which is bigger, a hectoliter or a liter? I know that a hectoliter is bigger based on my metric progression. Hectoliter is bigger, the number with it is smaller, 17. Then I'm going to go to liters. I know liters is a smaller unit, so therefore the number with it must be bigger. So I'm keeping that in mind. To get rid of hectoliters, mathematically, I need to divide by hectoliters. Since hectoliters is a bigger unit, the number with it will be smaller, and I always like to go with 1, because that's an easy number to work with. And then I put liters on top, because that's where I'm going first. Liters is a smaller unit, therefore the number with it must be bigger. So I ask, how much bigger? I go here and I say it is 1, 2 multiples of 10 different. So I would put 10 squared. That's 2 multiples of 10. Notice hectoliters cancel. Now I do the exact same thing with liters. I'm now going from liters to milliliters. To get rid of liters, I'm going to divide by liters. And I'm going to put milliliters on top. These are my conversion factors, remember from before. They're based on equalities. These two are equal to one another. So I can put one on top of the other. Either way, they still equal 1. Liters now, compared to milliliters, you see, liters is bigger. Therefore, the number with it is smaller. So I will put a 1 where liters go. Milliliters is a smaller unit. Therefore, the number with it is bigger. Question is how much? I go 1 step, 2 steps, 3 steps. Each step is a multiple of 10. 10 to the 3. Liters cancel, and I'm left with 17 times 10 squared times 10 cubed milliliters. So I know I have an exponent. When you multiply exponents, you add the superscripts. You add them. 2 plus 3 is 5. Right along with that, we go into scientific notation. Scientific notation means my measurement has a number greater than 1, less than 10. 17 is greater than 10. So I need to change this. I can do that by moving the decimal. I can make that 1.7. See what happened here? 1.7 is greater than 1, less than 10. Now I look at my same rule. It's beautiful. 17 to 1, my number went down. Therefore, to make sure I can do this, my exponent has to go up. And you notice I went 1 place. I moved the decimal 1 place here. My number decreased by 1 place, therefore my exponent has to increase by 1 place to keep the measurement equal. So that's times 10 to the 5 plus 1 is 10 to the 6th, and this is my final answer for this problem.